Good.
Good to see you all. Okay. Okay. Um, okay. Okay. Hi guys. How was the homework last week? First of all, let's go over the homework. Subi, what's going on at school?
Me?
Yes, Subi.
So we finished our assessment for solving system of equations and inequalities on Tuesday. So now, like today we started on causation and correlation, but I don't really understand it.
Causation correlation. Do you have a semester exam?
I don't know.
Okay.
I don't, there's not any upcoming tests next week in school.
Okay. Aditya, welcome back, Aditya. I hope you're feeling better. Okay, let me go ahead. Pratika, was the last homework okay?
Yeah, I didn't get to finish it because of the math Olympiad. My dad's making me like practice for it every day, so
Ah, that's good to know.
yeah,
Was it last time? How was it? Easy or hard?
it was pretty hard.
It was pretty hard.
The Olympiad.
Oh, was hard?
Yeah.
Okay. Okay. Okay, I see. Okay. So I had given some extra word problems. Okay, so the book pages were given as homework. Okay, so we had a conclusion. We did come to an end. Advik, did you do the homework?
Yeah, I did do the homework, but I wasn't able to like take a picture of the pages and submit them. I'll do them right after class.
Yeah, would be great if you submit it, ma. Avni, how about you?
I did all of the homework except the last section of the pages. I just submitted it because I didn't have a chance to submit it earlier.
Okay, you just submitted it. Okay, okay. Yeah, but I'm seeing your meaning. When I see it, it's in there. I'm happy. Okay. But did you check with the answer, Kima? That was something I wanted to ask you.
I didn't have a chance to.
But it's important, Amma. It's so
That's
important.
Priya. I don't think there's an answer key for the algebra
Why
one.
are you guys not asking? Sometimes I wait for you to ask. Nobody asks. Sometimes I leave it. Okay. So what the module tonight I'll do it. Okay. Annam, did you guys do the homework, Annam and Advait?
So I did the computer one, and I did the first part of the pages, but I submitted the worksheet one, but I didn't get to submit a picture of the pages.
Oh, but did you do it, Ma?
Yeah.
That's enough. What are they doing in school for Annam and Advait?
So today we did our introduction into causation and correlation, and I don't get it either.
Okay, no problem, guys. I will go ahead with causation and correlation itself, come what may, irrespective of the topic I wanted to go over, because it's not hard, it's easy. And it's a small topic which can be done this week and next. Okay, that makes a lot of sense for me to finish that. However, before I go there, okay, so what have you spoken till date? Meaning you've talked about correlation, positive correlation, negative correlation, all that stuff, right? Did you guys do all that?
We didn't talk about negative and positive.
What did you do then? Can you educate me?
So, she said that causation is when X is a direct cause of Y, and correlation is I don't really get correlation. It's like I don't know. It was like her example was
I
ice
think the
creams and
correlation is
forest
like,
fires.
yeah.
Okay, got it. Okay, let's see. Let's see.
Miss Priya,
Yama, go ahead.
is when correlation is like when something is not like really related to another thing, right?
and causation is like for example, it's kind of like causation is like a cause and effect, but correlation is not really related to like what something happens, then that doesn't mean that affects something else, right?
Makes sense. Makes sense. Makes a lot of sense.
Okay.
Shall we go ahead and review that?
Yeah.
Review, meaning we'll go ahead and learn that. Give me 1 minute, okay? It's just, meaning dynamically we are changing the topic, right? So yeah, I just need to make sure I'm getting you what you exactly need. Hold on. I was thinking of continue with the book, but really it's okay. Okay. Okay, let's get going with causation and correlation, okay? Remember our input-output table that you studied earlier? Remember our input-output. Okay, remember our input-output table that we studied. Let's say there's a tub of water, okay? I have some water in it, okay? 10 liters of water, okay? Now I start drawing a table, okay? Input. There's a small leak at the bottom, okay? So water drips. Water keeps on dripping, okay? So our mark in the sense 0 hour, 1 hour, meaning zero at the 0th hour, the number of liters in the tub is 10 liters. Then the first hour, it became 9. Second hour, it became 8. Third hour, it became 7. Now, do you see a relationship between the input and output? These are two quantities, right? These are two quantities, X and Y. You're trying to relate them. So any two quantities can be related in a graph, in an equation, or it can be anything. So this is one example where we are comparing any two quantities. Here, what are the two quantities? The one quantity was the number of hours elapsed. The second quantity is the number of liters in the bucket of water. This is just an example that I wanted to discuss. Okay. Now, let's go ahead and discuss a few definitions. Okay, I would like you to know what an association is. Association means a relationship or a correlation. A relationship or a correlation between two quantities. I'm going to write that down. I really want you guys to understand the word association. This means a relationship between relationship or correlation. Other word is correlation between two quantities. Any questions still here? Okay, now I really want you guys to know the word causation. I really would like you to, oh my gosh, I really would like you to know the word causation. Causation, that itself tells you, right? Relationship between two variables where one causes the other. That means what? Basically, one of the variables causes a change in the other. Causes a change in the other. Let me put it like that. Advait, did you get it? Did you get it? Advait, did you understand? Annam, are you getting it, Annam?
Yeah.
Okay. No, we are just referring to English words. Okay. Now, when there are two quantities, it can be any two quantities. Okay, a batch of cookies and then the amount of flour I use. So it can be any two quantities. Okay, I call them as X and Y. Now, if I say that X and Y are correlated, meaning I am saying there exists a relationship between X and Y. That's what I tell you. Then in that case, you can never say X causes Y or Y causes X. You cannot say this. Meaning X and Y do have a relationship. If I say that, it doesn't mean that one causes the other. You see what I mean? There can be correlation between variables. There can be relationship between variables. But you can't say that just because there is a relationship between the two variables, you can't say there is causation as well. Okay, we are going to see examples. Meaning, when two items or when two quantities have a relationship between one another, it does not necessarily mean one causes a change in the other. That's what I meant to say. So let's go ahead and see what is it. Okay, how about I'll give you scenarios, practical scenarios, and you're going to guess. Okay, let's see. Okay, how about this? Amount of ice cream sold. Amount of ice cream sold. I'm bringing in two quantities. Amount of ice cream sold. That is one quantity. And number of shark attacks. What do you think? Number of shark attacks. See guys, please volunteer to start answering. Only when one of you start answering in an unknown topic, others will pitch in. Go ahead. Okay, between these two quantities, do you think that there is just an association, or do you think there is a causation existing? It's just the words. Association means it's just a relationship, it's a correlation. There's something, meaning there's something that's existing where they have some relationship. But one may not be causing the other, one causing a change in the other is the cause. One becomes the cause of the other. So now these two quantities I've given you. So what do you think is present in here?
Association.
Why?
Because there are two quantities being like related, but it doesn't even have any like relation in one another. Like it's being not like compared, but they're like being
Just because like the amount of ice cream sold doesn't have to do with shark attacks, like they have no relation with each other.
Because X is not a direct cause of Y.
Exactly. This doesn't cause this or this doesn't cause this. You see? Okay. How about this? It's hot. Okay. It's summer. Okay. Temperature is on the rise. So that is one quantity. Is on the rise, okay. Number of ice cream sold is the second quantity. It has increased. So number of ice cream sold is the second quantity. Do you think, now I would like somebody else to take up and try answering. So temperature and the number of ice creams sold, is there an association or is there a causation?
I think it's causation because the relationship between the both of them are like X and Y support each other because the temperature on the rise means you need something to cool yourself down. So X supports Y. So the hotter the temperature, the more ice cream sold.
Exactly. So when the temperature increases, automatically people are thirsty and they feel like having more ice cream. So there is a causation that's clearly present between these two quantities. One causes the other. The temperature increase causes the increase in the number of ice cream sold. The temperature decrease results in the decrease in the number of ice cream sold. Are we all getting what is correlation and causation? Correlation is association. It's not a hard one at all. Now, how about this? I really want a nice sample where there is causation. Okay, temperature. Yeah, temperature and ice cream sold itself we can have. Okay, temperature. That one is a good example. Temperature, ice cream sold. Number of ice cream sold. We'll have that same example, okay? Temperature was 10 degrees. Number of ice cream sold was 2. Okay, then it was 50 degrees, became 10. 100 degrees, it became 100. So 120 degrees, it was 200. So now when I plot it, right, in the xy coordinate plane, right, we know x, the independent variable, causes the output. Output is the number of ice cream sold, which is on the y-axis. So now we have, I don't want to go by tens. I would like to go by 20s. 20, 40, 60, 80, 100, 120. Now, here I would like to go by, starts with a 2. My gosh. Let me go ahead with a 50, 100, and then I have a, what do I have? 150 and a 200. Okay. So now when I put it in a coordinate plane, right? 10, comma 2, somewhere here, right? And then 50, comma 50, comma 10, somewhere here. And then 100, comma 100, somewhere here. And then 120, comma 200, somewhere here. Okay. So now, do you see, meaning somewhere here, basically, I should, okay. Now, when you try to connect most of these points, what do you get? It's a little up, it's a little up. It's okay, but there are 2 points in the line. Now, do you see when the temperature goes up, the y value goes up? Do you see? So when the temperature goes down, the number of ice cream sold comes down. So here, if you're able to connect most of the points by a line, I can say that there is a strong correlation. Do you get it? Strong association between the two variables discussed. You get it? Suppose if I plot the points, there are some other 2 quantities given and the points are like this. What do you think? You can't even make out any line. Here, when you, okay, before I go to that example, right? What do you think about the correlation in here? What do you think about the slope of this line? How is the slope of this line?
Positive.
So it's a strong, when most of the dots come within the line or very near the line, there is a strong positive correlation. You get it? Okay, now a while back I discussed that there is a leak in the bucket and stuff, right? Or what else I can say? I want one more example of negative correlation. I'm just thinking of cases. Let's see. I don't remember. I don't have anything.
Wait, Priyanti, this is a case of causation, right?
Yeah, this is a case of causation, 100%. Okay. See, okay. When there is causation, definitely there is association, right, Ma?
Oh, okay. So you can say everything that is causation is correlation, but not everything that is correlation is causation.
Good. So whenever you have correlation, I cannot say that there is causation, but you already found out something between 2 variables that one causes the other. If one is the cause of the other, definitely there is association between them, right? You get it?
Yes, I understand.
Okay. Now, when your slope is positive, suppose when you draw a line, meaning when you draw the points describing the relationship between the 2 quantities, if you get a line like this, let's say the points are like this. What sort of a correlation is this? What sort of a correlation?
Like cross correlation?
Huh?
Cross correlation? Or like
Yeah.
strong?
Strong. It is strong, definitely.
Negative.
Okay. Negative correlation. Do you see? Strong negative correlation. Any questions? Okay. Now let's consider there are two quantities, but when I draw the relationship between them, right, I get something like this. What is this?
Parallel lines.
Or
No,
weak
no, no, no,
positive
I can't draw two
correlation.
lines. I can draw only one line, okay? So how many ever points are up? Those many points are down as well, okay? And some of the points are on the line. Do you see? So there is correlation, but
So weak positive.
yeah, weak positive correlation. Any questions?
Priyanti, isn't it like being a weak or a strong correlation? Is that like relative to the line?
Yeah, see, if the points are crowded around the line, less crowded around the line, I would say, then it is weak. Okay, if many of the points are on the line itself and they're so close to the line, strong positive. I'll show you graphs, don't worry. I'll give you examples, okay? So I just want you to know these terms are coming up. Now, this is weak positive. How about this?
Weak negative?
Yeah, you get it?
Mm.
Somewhere they're trying to align to a line, but they are not. So it is weak negative correlation. This is just by viewing the graph, we are able to come to consensus, okay? Sometimes the shark attacks and the number of ice creams sold, okay? This is the number of shark, this is the number of ice creams sold, okay? This is the number of shark attacks, the first one that we discussed, right? If I'm able to draw the meaning, if I form a table and put that XY coordinates into the graph, let's say I have something like this. What is this? What do you tell for this one?
No correlation.
No correlation. The points are all over the graph. There is no correlation even. There's no relationship even between the two. You got it? Leave alone causation. If there is no correlation, there is no causation. Got it? So it's just logic, okay? But then the problem is,
Could you call it coincidental?
which one?
Like correlation and association. Could you call it coincidental? Or is it not always the case?
Sorry, Advait, I didn't get you. Is it
Could you call it coincidental or is it not always the case?
coincidental? Uh, it need not be coincidental, right, Advait? Why do you think it's coincidental?
Because like remember shark attacks if like
Oh yeah. See,
heavy
when the
normally.
number of shark attacks and the current example that we discussed, right? If there are some increase or decrease there and here which resemble a pattern, no, yeah, it is very coincidental. It doesn't have to be causation in that case at all because there is not even correlation. You get it? Make sense?
Yeah.
Hmm. Yes,
So
ma'am.
basically, if there's no correlation, then there's no causation.
Yeah. Makes sense, right? It makes sense to say that, right?
Yeah. So then that means, but like, it's not, if there's no causation, there's no correlation, right?
If there is no
Cause,
what? So we repeat. Repeat. If there is no,
if there's no causation, is there any correlation?
what do you think?
Uh,
Tell me whatever you think.
I'm not
If
sure.
there is no causation, would there be correlation or not? Anybody can volunteer.
If it correlates, then it doesn't always have to be causation.
Correct, Ma. That is true. But what Subi's question is, she's saying there is no causation between two quantities. Okay. Can there be correlation? She's asking.
Uh, maybe if you switch the y and x values. like if you say that the more heat there is, then the more people sweat, that would be your X and Y, so there would be causation. But then you could say the more people sweat, the higher temperature gets. There's correlation, but there's no causation.
It's a good one. That's a good one. It's a good one. So, okay. Otherwise, see, number of hours I study. I feel like this is a good one too. Number of hours I study, the score I get. Okay, when I plot a graph like this, you study 1 hour, you get 10, 2 hours, you get 20, 3 hours, you get 30, 10 hours, you get 100. This does not mean that just because you spend this many hours, you're getting the score. That is true. But then there are other factors that are pitching in to get the score, right? It doesn't depend on just the number of hours you study. You see, there are so many factors like did you attend the classes? Did you listen to the professor? Did you do the homework? So many things are there. Just because you sit and study and break your head, right? It doesn't mean that your score improves. Here, it's more of a correlation. There is a relationship if I see the numbers. But then there is no causation. Number of hours I study is not the cause of increasing the score. Okay, I would not say just because you sit there for so many hours, it doesn't have to be. One person can, meaning there can be one person that doesn't study at all, but has been attending the classes and doing the homework. So he gets it because he understands it there and right there, and he does the homework. He doesn't have to sit and study for hours. So whereas there can be one another person that sits and studies for hours and hours and hours, but then the score is not seen because he did not get it and he ended up spending more time. And similarly, number of people who sweat and the temperature. All people need not sweat when the temperature increases. So one is not the cause of the other. Still, there is correlation. Okay, how about this? What type of correlation is this? Do you like to... how about this? The line that you draw, you try to draw connecting the points, right? That line is called the trend line. The line that you try to draw connecting the points, right? That's called the trend line. So what type of a correlation is this, guys?
Positive, strong.
Yep, strong positive correlation. Can I move on? Okay. Now, do you all have the computer, calculator with you? Do you all have the calculator with you?
I do.
Okay.
I don't.
Can I go get mine real quick?
Yeah, would be nice, really. Amma, always bring your calculator, Amma.
I have it. It's just upstairs with me. I came downstairs to take the class today.
Okay. So now I'm going to give this. The thing is, I was always telling you from a bird's eye view, in the sense I was showing you in a graph. I said if the points are aligning with the line, then please say it's strong positive. Otherwise, I said it's weak positive. Sometimes the other way, if x increases, y decreases, and it has a negative slope, I was saying it's negative correlation, strong or weak. Just by observing the graph, I was saying. But in Algebra 1, as a part of EOC, I've always seen every year they give you proper XY data, two quantities with their numbers. They give you and ask you to find what is the correlation. What is the, correlation, the amount to which two quantities are associated can be given by what is called correlation coefficient. There is a quantity that can measure the relationship between the two quantities. Here, let's consider the same quantity here, x and y, height of incline and distance traveled. Some quantity, don't worry about the quantity, okay? They give you the points. They give you this 1 point, this 1 point, this 1 point. Now, so you can draw a table, okay? Or I'll give you the table. I'll give you the related table. Now, for you to it looks like it's strong positive. Advik just said that it's a strong positive correlation. Looks like it. How do you determine with numbers? Statistically, you need to know, hey, This definitely represents, but just by seeing, you cannot approximate it, right? So how do you define it? There's something called correlation coefficient, which is often represented by R, the letter R. Okay. In statistics, right? These are all a part of statistics. In statistics, this correlation coefficient can range from 0.1 to 0.99, meaning 0.1 to 1, okay, 0 to 1, I would call it that way, 0 to 1. Correlation coefficient can range from 0 to 1. So now, Pratika, do you want to make an educated guess? -1 to, I'm sorry, guys. It can range from -1 to 1. Oh, wait, guys. Let me try it properly. -1 to 1. Okay. Now, if my correlation, this is the possible values of correlation coefficient. I'll tell you how to find it later, okay? If the correlation coefficient is like a 0.9, what type of a correlation is it, guys? What type of a correlation is it?
If the coefficient is 0.9,
It's positive.
strong positive.
Yeah, strong positive.
How come the range is from -1 to 1?
I'll tell you. Okay. Now, if the correlation coefficient is something less than a 0.5, let's say the correlation coefficient came to be 0.4. What type of a correlation is that? Anybody shout out, it's just a discussion.
Weak positive.
Yeah, good job, Pratika. Weak positive, correct. Now, I go to the negative side. My correlation coefficient is a minus 0.8. What type of a correlation is that?
Strong negative.
Yeah, strong negative. So anything in between this is weak. You got it? More than that is strong. Positive or negative, you decide based on the sign. You got it? Okay. Now, but how are you going to calculate it? That's a challenge, right? That is what is required for you at school. Let's see this one. Then after this, we'll see some graphs. But before I go ahead and calculate, right, I really want to present some graphs to you and ask you, hey, this is positive correlation or negative correlation, weak or hard, weak or strong, all that I want to ask. Okay, let me ask you that and then go to tell you how to calculate the correlation coefficient. Okay, just give me a minute. Causation, I wanted some notes. Okay, good. How about this? Okay. See, literally one nice example for a causation. Okay, you hit your finger with a hammer. Okay, your finger swell. Automatically, one causes the other, right? So that is what is causation. You get it? That was the only reason your hand swell. You got it. You see it. That was the cause of the swelling increase. How much you hit, it swells more or less, right? So that is causation. Okay. Now let's see. I really want you. Okay. How about this? Okay. Okay. The number of minutes you exercise increase. The number of minutes you exercise increases. Your total weight decreases. Your total weight decreases. Is there correlation? Is there causation? You want it to be a discussion or in chat? You can let me know. There's a situation I've given you. The situation is the number of minutes I exercise every day. The second quantity is the second quantity, let's say the second quantity is the calories I burn. It's easier. Number of calories I burn. So is there correlation? Is there causation? Meaning, I want to get an answer. Correlation, yes or no. Causation, yes or no. 2 answers you need to give me. 2 answers you need to give me, Subi. 2 answers, please, Savni. Please, Subi. 2 answers. Causation, what? Correlation, what? Yes or no on both. Good, Annam. I think you all got it, guys. Everybody got. Advik, I changed the question to number of calories you burn. What do you think about it?
Wait, can you repeat the question again?
Sorry, I think I changed the question. It was my bad. But the question I finally wanted to ask you was, the number of minutes you exercise increased. Okay, the calories you burn. That's right, Anand. That's right, Advait. Pratika, correct. Subi, why there is no correlation? Yes, Advik. Why there is no correlation, Subi?
Because both the quantities are like related to each other, like they have a relationship.
Yeah, they have a relationship. So
I thought like causation there would be no correlation because
Amma, no, wait. If there is causation, means if one causes the other, then there is a relationship between the two, right? If the relation is called correlation. If there is causation, if one causes the other, both are present in it. You got it? But it is an example of causation. You got it?
Yeah. So if there is causation, then there is correlation.
Yes.
Okay.
Okay, now, okay, R values. How about this? R value of minus 0.87. Aditya, good job. What is R value is negative 0.87. What type of correlation it is? R value equal to negative 0.87. Shout out what type of correlation it is.
Negative, weak correlation.
Negative, strong correlation. It's above minus point. See, it's above minus 0.5, right? It's strong negative.
I thought you said 0.1.
I said minus 0.87, right?
Oh, okay.
Okay, how about this graph? The first graph suggests what correlation? Anybody can answer. Please feel free to shout out so that you know you make a mistake, even if you make or not make.
Strong
Anybody?
positive.
First is strong positive, R equal to 0.7. How about R equal to 0.3?
Weak positive.
Okay, I would like somebody else to answer. Is it okay, Advik? R
Yeah.
equal to 0?
No correlation.
Good job, Abni. How about R equal to negative 0.7? Annam or Advait?
It's strong positive correlation.
Which one am I? I'm asking about this.
0.7.
No. Yeah, Advait, we are here, Advait. They all told this. We are here.
Strong negative correlation.
Good job. Pratika, next one.
Weak negative.
Is it negative? I thought it's positive, right? Oh, yeah, negative. I'm sorry, guys. Minus is here. Okay, correct. Sorry, I didn't see the line. Yes, weak negative. How about this, Ma? Who wants to say?
No correlation.
Yep. So you all are good at it, right? Okay, now finding the correlation coefficient seem a big issue to me.
Yeah.
Yeah, Ma?
I have a question.
Please
So
go ahead.
what if like there's an variable that's equal to either 0.5 or negative 0.5?
Oh, good question. Hmm. Exactly 0.5 they won't give you for that matter because you cannot do both. Okay, let me, this has come up so many times. I'm checking now, hold on. Then I just don't want to say anything and misguide you. 0.5 correlation coefficient now. It's not either strong nor See, it's moderate positive correlation or moderate negative coefficient. They are moderately correlated. If they won't give you 0.5, okay, I can assure that, okay. And even if they give you, it's moderate positive or negative correlation based on the sign. Make sense? But they won't give you 0.5. Make sense, Subi?
Okay.
I want to ask you more questions. Hold on. So correlation does not imply causation. I've told you that, right? Okay. And you know what? We are graphing the x and y with the points, right? What sort of a plot is that?
A scatter plot?
Good. That is called a scatter plot because points are distributed everywhere, right? It's called a scatter plot. Good job. How about this? I'm showing you two graphs. Now that's a little difficult one. Let's see. The right one, what type of correlation does it show?
Strong positive.
Strong positive.
Which one, right or left?
Left.
Oh, I asked you about the right one.
Oh, right.
This is strong positive, correct. This one, second one? What is it?
Weak positive.
Weak positive. Good job, guys. Okay. Now, I will erase this and we'll move on.
Miss Priya,
Yeah, ma?
is it also like if there's so many points on a graph, then it will most likely be weak?
Not necessarily. Why do you think so, Shubhi? Wait.
Because in like the examples, I feel like almost everyone that had less points were
Not really, ma. There can be points like this. What do you think about this?
Hi, Ma.
Yeah, ma. How was it?
It was good.
Good.
I was impressed.
Okay. Go ahead, guys. How about this? Subi here. You see Subi?
yeah.
Depends on how crowded the points are. Okay, there are two graphs on the board. Will somebody want to say what? Aditya, I don't know whether you're feeling okay to answer, but I will ask Adarsh for today. Who wants to say? Please, there are two graphs, guys. Please volunteer and say quickly and we can move on.
The left one I think is strong negative.
Nice, ma. Right one?
Weak negative.
Yep. Good job. There are more guys. Hold on. How about this? How about these two? Good ones. Tricky ones. Not a tricky one. There's nothing to be tricky about this topic. That's why I thought, okay, somebody said correlation, so I thought I'll finish that. It's an easy topic. Go ahead. Another, how was it? Another 10 minutes. Go
No
ahead.
correlation on the left.
Okay. The right is confusing.
No correlation?
Yes, there is no correlation. Got it? Nice. Okay. You know why? You know why? I don't know whether I can get that picture back.
Like why there's no correlation?
Yeah, you know why? Yes, see here.
Because no
There is
change.
a straight line, okay? No doubt there is a straight line. But then the line is horizontal and the slope of it is 0. 0 means there is no change at all. Output is not even changing. Then where is correlation? You get it?
But Briandy, if there's no change, then doesn't that mean it's just no causation? And then like there's
I
no
like your
causation, but
uh-huh.
it could be correlation.
But there is no meaning okay. You how do I take it? Yeah, your thought process is correct, but but do you see a relationship between the two quantities? Ma? No, right? There is no relationship. Come what may, it is the same. You see what I mean? Come what may, your y value is the same. You're not able to accept it.
I mean, if it's the same, doesn't that mean it's correlation?
No, there has to be some sort of honestly, okay, let me come back to you next week with a better explanation. Okay, let me think about it and come back to you. But that's a nice question you've asked. Makes sense? Definitely there is no correlation, but why? I mean, I see where you're coming from as well. So it's a straight line, right? So let me answer that next week. Okay, but remain me, Anam.
Yeah, I'm writing it down.
Thanks.
Priya,
Yeah, Ma, go ahead.
yeah, back to the previous one.
Oh, you wanted?
I'm
Okay, wait.
almost done writing.
Oh, sorry. Oh, sorry. Oh, you wanted, Amma. Okay. Okay, guys, I'll get you that notes, whatever I'm referring to right now, I'm saying. So can I put it in your Google Classroom?
Yeah.
Yeah. So why do you want meaning? I'll write it down. I don't see why you should not write it down. But what I meant to say was you should also be able to refer to it later. So I'll put it there. But for that, please don't skip writing. So let me go ahead and write that in your Google Classroom. Give me 1 minute, guys. Algebra 1. I'll put it as material. Causation, correlation, right? I'll also search for some causation. Web link. Okay. I really want to show you in the link. Okay. Okay. So that's done. Google Classroom has it. Now, can I show you how to calculate that before that? 1 minute. Correlation, causation. Okay. Okay. Now you're drawing a scatter plot and you know about a trend line, right? Okay. Okay, I really want to ask you some questions more and then go with. Okay, how about this? Okay. Okay, from a table, you'll be able to form a line, right, guys? From a table, you'll be able to form a line, right? Would you be able to do it? If I give you a table, you'll be able to form a line, correct? Okay, now let me give you a table. Do you know how to write the equation of this line? I don't want you to write the equation of this line. No. I don't want you to find the slope and stuff. That's not what I'm asking, okay? I know that you can do it using y equal to mx plus b. But can you type it into your calculator and find the equation? Because why I'm saying this for the first time, I want you to use the calculator rather than finding the slope and intercept is in correlation causation, the tables will not be this easy, okay? It is going to be in decimals and it's going to be very hard to find out these. So why don't you type it in your calculator and then find the correlation coefficient? Can we try? Do you know how to do it in the calculator? My yes, no, please quickly answer. I'll show you otherwise, that's all.
I don't know how to do it in the calculator.
Okay, so then let's do it together. TI-84 online calc. I wish I installed some steps to use test now. I will share my screen, guys. Okay, I'm sharing my screen. You're seeing the board, right? Okay, but where is the calculator? This mouse. T84 graphing calculator. Okay, now can one of you read that for me, those numbers? Are you, oh, you're not seeing the graphing calculator. Okay, wait. Can one of you write down those numbers? 3, 4, 5, 6, 12, 15, 18, 21. Can you please write it down?
I wrote it down.
Good, thanks. Now, let me share the graphing calculator. Yeah, now, do you know how to go ahead and type in the table?
No.
Stat edit. Stat edit. Now I'm going to type the stat edit. 3, 4, 5, 6.
Miss,
Okay, got it? Yama? Yama?
how did you get there?
Which one, ma? Stat edit. Stat edit. Did you get it?
What is stat on this?
Stat edit. Oh, stat button is here. Where did I put it? Stat button is here. See, second last button, stat. And then you have the edit coming up on the screen. Click on that, you will have the table.
Okay.
You got it?
Oh, I got it. Thank you.
Okay. Now you put in the table, right? Did you all type it in? Did you all get that? Are you able to type, ma? Did you type it?
Wait, what were the last two numbers?
Oh, the last two numbers you want. Okay, hold on.
Priya, I don't know the second column of the table.
Just use the arrows.
No, like the numbers.
Oh, you need the numbers. 12, 15, 18, 21. 12, 15, 18, 21. Got it?
Now what do I do?
Excuse me?
Uh-huh. Go ahead, Avni.
Can you repeat the first column?
3, 4, 5, 6.
Okay.
Got it?
Yeah.
Okay, now we might be into a surprise, but that's okay still. Okay. You all got it? Now, so you all entered it, correct? You all have it ready, right?
Yeah.
Okay. Now I'll go to start button again. Go to calc. Do you all, oh, I'm not sharing. Okay. Go to stat calc. Stat is the second row, last button. Stat calc. Then go down. There is a linear regression. Do you get it? Linear regression. Regression is you have a lot of points you're going to try to plot and then find some relationship. Linear regression, number 8, written, enter. Now, can I move on, guys? L1 is correct. L2 is correct. Those are the values, right? And then you can come to store. You can store it into a variable as well. Guys, are you all with me? Where are we?
Miss Priya.
Yama?
What do I do after I fill out the numbers in the table?
Fill out the numbers on the table, then press the stat button.
Okay.
Stat calc, go to number 8, linear regression.
Oh, you press them at the same time.
No. Just press stat and then go to calc. There's an edit and calc coming, right?
Yeah.
Go to calc. In that, go to number 8.
I can't find it, Miss Priya. There's just a graph.
What you can't find, Amma? Where are you?
I pressed stat and then calc, but then it's like showing a graph.
No, you did not press You pressed stat, okay, and then did what? Okay, can I show you?
Yeah.
Okay, I'll show you. Oh, I'm already sharing. Do you see the board? Do
Yeah.
you see the board? Okay. Let me go back wherever I was, okay? You started the table, right? Where's the table? I don't know. Where's the table? Hold on. We went to stat and then we went to edit, right? Here is where you are, correct?
Yeah.
And after that, what I'm saying is press stat, the button. See the button I'm pressing, the red color. See the screen. Okay. Can I move on? Then press this arrow, go to calc.
Okay. And then the eighth
And then
one?
you have to choose the 8th one, linear regression.
Okay.
Enter. You got it?
Okay, I got it.
Then enter. L1, L2, correct. The column names are there. But then the regression equation should be stored into a Y variable. They're asking, store your regression equation. Yes, you have to store in some variable. So press vars. Do you get it? Then go to Y vars. Function. It's a function. You're going to store it as a function. It's a line equation that's going to come. So you're going to go to vars, Y vars, function, Y1, enter. Now you're done. Come to calculate, calculate. You're getting an equation, but you're not getting the regression coefficient. Correct, guys? Do you see it? You're not getting the regression equation. Did you see? Meaning you're getting the line equation, but you're not getting the regression coefficient, right? Guys, where are we, guys?
I'm on the Y vars color.
Okay. Y vars Y1 choose.
Is
Y vars
it like the first option that says window?
Y vars window. Where is the window? You want me to go ahead and see? Where are you? Where are you?
This is how it looks for me.
No. Wait. We go to stat. You are using calc, then linear regression, correct? Then if you press enter, you didn't get it, right? Make sense? Here, Subi, are you with me?
Yeah.
Come down, go to store regression equation. Press on vars. Go to Y vars using the arrows up, down, right, left. Vars, select Y vars, select function. Number 1, enter. Y1, enter. It gets typed there. So you're going to store it in the variable Y1 and press calculate. Nothing is happening. Okay, nothing is happening. You're not getting the regression coefficient. You know what? For you to get the regression coefficient, press second and second 0 button. If you press right, there is something called diagnostics on. Where is it? Second and 0 button. If you press, you should have see, there is a diagnostics on. You have to press enter. Okay, done. Okay, then go back. Go back to what? Stat, calc, linear regression, enter. Now, again, the same problem for us. We have to store it in the vars. Here, come to Y vars. Yes, enter. It is storing. Come down, calculate. Now see, the regression coefficient is shown there. Did you see it? Did you get it, guys? When the regression coefficient does not appear in your TI-84 calculator, what you need to do, you have to press second 0 button. Okay. In that second 0 button, keep coming down. There is an operation called diagnostics on. When you press on the diagnostics on enter, it'll say done. After you get done, you can go back, stat button. You're always in statistics. Statistics, calculate linear regression. X1, Y1 already stored. Okay, you want to store the linear equation? Yes, I definitely want to store it as a variable. Go to Y vars, function. Yes, I want to store it as a function. Y1. Now, come down, calculate. Did you get it, guys? If you have a question, you can see the video again. Okay, guys?
Okay.
Any questions? So that is your regression coefficient. This is how you calculate. Usually, there's always one question in your EOC. To find out the correlation coefficient, they give you a list of table values. Got it?
Yeah.
The R value, don't go with the R square value, okay? R value is your regression coefficient. There's a strong positive correlation for the table that we discussed, okay? I'll stop here. If you have a question, stay. Otherwise, we'll log off. See you all next week, guys. Was it much better? Subi and Annam, was it better?
Yeah, I understand it now.
Bye, Miss Priya.
Bye, ma.
Bye.
Bye. Good job. Bye-bye.
Thank you.
Bye, ma. No problem.